Example 4, using elimination. As we try to solve these systems of equations, we want them to be in standard form. So as I look at this first equation, it's in the slope-intercept form. It just doesn't do anything for me. And so what I'm going to do is move that x into the first position. Down here, that means equation 1 can be written as negative x plus y equal negative 4. Technically, according to our book, that's not standard form because we want that first term to be positive, but for this elimination technique, it doesn't really matter whether it's positive or negative. Now as I look at the second equation, I do have a little bit of an issue with the second equation because I have all these fractions here. I'm going to multiply the second equation by 2. If I multiply the second equation by 2, I can get rid of those fractions. So equation 2 can be transformed, if I multiply by 2, into 2x plus y equaling 5. Once I've transformed these so that they go x, y, answer, I can determine which variable I want to get rid of. I can decide either to get rid of the x's or the y's. It's a completely random choice. It's arbitrary. It's up to the user. And so for this one, I think I'm going to go ahead and get rid of the y's. I want the y's to be equal but opposite. I can achieve that by simply multiplying the first equation by negative 1. So if I distribute this negative 1, I can create an x minus y equaling 4. That's my equation 1. For equation 2, well, I'm simply going to rewrite it. Equation 2 will be 2x plus y equaling 5. I've achieved my goal of getting the y's to be equal but opposite, which allows me to move to the next phase, which is called linear combination. I add the two equations up. X plus 2x creates a 3x. The whole point of this process is that you're able to remove one of the variables. So on this, the y's drop out. 4 plus 5 is 9. Woohoo! Look at that. 3x is equal to 9. Easy to solve. Divide by 3. X is 3. Half done. I can come up here. I know that x is 3. And the way that this problem was originally set up, I had this slope-intercept form, means that it's very conducive to plugging the 3 in there. 3 minus 4 produces negative 1 for a y value. And that problem's solved. Example number 4, using elimination.